All right, good deal. Well, I appreciate everyone's time. I know we're expecting a big turnout here today. So we can go ahead and jump to the next slide here. Obviously we have Alex Berry. He's the most important one on the call here. He's the Granta expert from ANSYS. And then, I guess the official title, I'm the Vice President of Operations here on the RAND simulation side. So just to get the fundamentals out of the way, RAND Simulation is a strategic North American channel partner of ANSYS. I'm sure most people on this call are affiliated with the product development community and at least, have a cursory knowledge of who ANSYS is, the global leader in, engineering simulation, solutions. We're not here to talk about that today. We're here to talk about one of the, really innovative acquisitions that ANSYS made a while back around Granta. In complete transparency, I've spent the last 20 years of my career in product design and development and in the world of simulation, and I'm really excited by what I see from Granta. First and foremost, because one of the key components of this platform really has nothing to do with simulation. There's two key platforms we're going to talk about today. Like most ANSYS product lines, it comes in different, flavors, and we'll talk about two fundamental components or flavors today. One is called MDS. We won't focus as much on that, but that's essentially a much larger materials database for those on the call that might be using, ANSYS mechanical simulation products. But for everybody else, I presume, you're on this call because, you're in product development. Obviously your designs involve different types of materials, some of which are not very readily available in published data. So that's what the Granta Selector is all about, and that's going to be the vast majority of what Alex walks you through today. So really not trying to sell you anything. This is meant to be an educational webinar around what Granta is now that it's part of the ANSYS family. And if you deem that it's relevant to some of the either challenges or initiatives you have around materials moving forward in your product design process, obviously we'll let you know how to contact us after the call today. But just to sort of set the stage, for those of you that aren't that familiar with Granta, they really are the world leader in, I guess, what I would call materials data and visual comparison, platforms. So Alex will show you specifically what I mean by that. But it really enables you to quickly evaluate all of the technical, economic, and environmental performances of different material options. So to put it bluntly, this is a tool that allows you to make educated, informed, decisions around what materials to choose for your product design, goals and product lines. You'll see that you can compare different types of materials, lots of criteria, filter criteria you can put in, and ultimately it'll narrow it down for you to say, hey, if you're looking for, coefficient of thermal expansion between this range and you want to keep the price to X but still meet all your performance goals, it'll quickly identify the best materials for you. So again, this component of Granta really is independent of simulation, so I think we'll find it's very relevant to just about everybody, hopefully everybody on this call. So Alex will walk you through demonstrations to show you the tool and how it works. I think he's got a case study queued up as well to show you how somebody in the sterilization environment was able to use the selector tool to really hone in on the best material option and balance performance with cost and have confidence moving forward. So with that, Alex, I'm going to turn the floor over to you and let you walk the audience through Granta.
Great. Thanks for that introduction, Jason. So to get us kind of started, as Jason mentioned, the acquisition of Granta by ANSYS, which happened in March of this year, was really kind of a change in directions for ANSYS specifically. So this presentation will be relevant for all of you. Even if you don't use any ANSYS products, this will still be relevant for you. And kind of just to get us thinking about the right idea of materials information, we'll start with this idea of what do you think about when you make a product. So traditionally, there's three main things that you think about: shape, function, and manufacturing. And to this point, they've really been addressed by the programs you see below. So we have, PTC Siemens on the CAD side, ANSYS obviously ran from the CE side, and then there's a bunch of companies now that are vying for computer-aided manufacturing. It's actually using robots on the actual floor of a specific product to create them. And so where does that leave materials information technology? So that's really where we sit here at Granta. And our goal is to digitalize materials.
So what you're seeing here is a graph of, on the y-axis, we have degree of digitalization, and on the x-axis, we have time. And we'll see that there's really a lagging behind as far as materials are concerned in digitalization. A lot of materials data now, if it exists, is somewhere deep inside an Excel file or a Word or PDF file, and it's quite a technically complex domain, so it's very difficult to understand for most people. There's a lot of specialist data sets, and the ownership is spread apart across multiple departments. So really our goal is to really push materials information and start to digitalize it in a more complete form, like some of the more modern products you would see in something like human resources. You can think of applications like Salesforce and finance. We have things like Bitcoin now, which are gaining traction. So there really is a push to digitalization, and our mission at Granta is to help materials reach a higher level of digitalization. So what's the history of Granta design? As Jason mentioned, we like to think of ourselves as the world leader as far as materials information is concerned. We were originally founded back in 1994 by these two wonderful gentlemen you see on the left-hand side. So that's Mike Ashby and David Sabone. I had the pleasure of meeting both of them. Really great people, really focused on education at its core. They love students and they love people that love to learn. And that's kind of where Granta started. It started as an educational platform. So really, Mike Ashby was the one that originally has written multiple textbooks on material selection as far as product design space. And Granta formed originally as a material selection company. So there's a product, CES Selector, that was originally formed for the University of Cambridge to be used in classrooms. And over time, as the company became more and more successful, they offered a business alternative, which is what I'll show today, which is Granta Selector. And then over time, we developed many, many solutions for different product areas. And you'll see all the way up to restricted substance and additive manufacturing. So this is, kind of more future-based applications. And as I mentioned, in March, Granta Design was acquired by ANSYS, and so that's why you are sitting here listening to me ramble on today. But essentially, the product line for Granta, what do we have to sell to you all? We have two main things we'll talk about today, which are the Selector product. That's what allows you to make smart decisions. This is kind of what Granta started as a company, was through this Selector product. And then we'll look at MDS. So that's a specific data product, and really it contains a lot of simulation-ready data on 700 plus materials, and this is going to be focused on any of you in the audience who are ANSYS users, because it actually allows you to directly access that materials data from within the ANSYS environment. So we're going to start off with Granta Selector today. And really, to get us in the right mindset when we go into this demo, we're going to think about some of the implications of poor material choices. So what happens if you choose a material that is not correct for your product? And we'll see that in the product design lifecycle, which I've outlined here, all the way from material project in blue into the production phase on the right-hand side, there's obviously an increasing amount of investment the closer you get to production. And so what happens if you don't choose the correct material is that you would have to actually repeat these individual development steps, or you would have to have increased costs because you're repeating these steps, increased time to market, all things that we don't want to hear. And if we end up getting all the way into production, then we end up with a product that is either non-competitive or that requires product recalls or warranty returns. And so where does Granta Selector sit in this process? Well, Granta Selector, we try to identify these issues early on in that product development lifecycle. So when you're identifying potential solutions, you can hop into Granta Selector and look at all the different materials, as Jason said, and choose which one is optimal for your product before you get to production environment. So what is Granta Selector? It really includes two main things, and the first of which is an encyclopedia of materials data. So this encyclopedia we call Materials Universe, trademarked, and this is a product that's put together by material analysts. So these are experts in material science from the Granta side. It has over 5,000 different materials of relatively different classes, so all the way from polymers to metals to composites. And it also has, we'll talk about it a little bit more on the next slide, but we also have in Selector, we have this idea of visualization, filtering, and estimation tools. So all of these tools will allow you to make that decision early on in your product lifecycle about which material is the best for your specific application. So these two things together make up Granta Selector, and this is what enables you to make these smart materials decisions. If we look a little bit more specifically on the types of data that's available, so this Material Universe product contains, as I said, 5,000 different materials, and each one of these materials is linked to a specialist database. So what that means is that if you find a material in Granta Selector, you can actually look for a version of that material that you can actually buy through a supplier. So all of these are those specialist material data sets, and we'll look at Prospector Plastics a little bit in this demonstration. So you'll see that's quite a large space as far as applications go. And the second part of this is the actual selection tools. So I'm just going to put a couple selection tools out here for you to get familiar with, and just to keep in mind that all of these selection tools operate by the same selection methodology. So what do I mean by selection methodology? It means that we actually break down the design requirements. So what are the functions of the product you're creating? What constraints must be met, and then what objectives are used. And we can actually start to screen and rank on those objectives and constraints, and that will give you your list of top candidate materials. So this is the process that was actually outlined by Mike Ashby back in 1994, and what all these textbooks are based off of. So be easy when you're using Granta Selector. You know that there's a ton of research that's gone into this product. And once you find that material, you'll notice that you can also export it. So not only can you export it to ANSYS, but you can actually start using these material models in Abacus or Creo or SolidWorks, whatever simulation or CAD platform that you choose. So now that we've got an idea of what Selector is, let's actually get into the meat of this presentation, what you all came here to see, which is that case study. So the case study we're going to look at today is a sterilization case. And we have two main issues with this case. It's currently made out of a stainless steel. And the first thing is that it's far too heavy. So if we have to carry 5 to 10 of these cases at a time, or we're on a little rolling cart, these are just way too heavy for us. So the first thing we're going to look at is actually being able to optimize by mass. And then the second biggest thing is that we can't check what's inside. So any of you who have worked in the medical industry will know that sterilization of parts is very crucial, right? We don't want the surgeon using a needle that's been on the ground or that fell on the ground accidentally. So we want to be able to look at what's inside this case without breaking the quote-unquote seal. So just to define, as I said, that systematic methodology, what's the function? We have a panel loaded in bending, which is stiffness limited. And our constraints here is we want it to be transparent. Obviously, it has to be medical grade, and we're looking for things like impact resistance, just in case we do drop it. So the objectives, as I mentioned, let's make sure that we minimize mass, first of all, and that we can look at minimizing cost as well. As a materials expert, I'm asking myself, what polymers should I be using for this particular sterilization case? And that's when we can actually open up CES Selector. So what you're seeing now is the home page of CES Selector, and on the left-hand side is essentially the ability to actually look at all the different materials that we're selecting by, and we have a couple tools to actually visualize and put some functions and constraints as well. On the top bar, we have a couple of different tools, things like Eco Audit and Synthesizer, which I won't talk about today, but will allow you to actually select based on the eco considerations as well as the part cost. So if you want to estimate something based on producing 1,000 parts versus 10,000 parts, you would use one of these tools above. But just to get us started, we're going to go to the left-hand side, and we're going to choose from the list of materials that we'd like to filter by. So as you see, there's quite a lot of different materials. As I mentioned, we have an encyclopedia, really, and that's all the different materials that are available within Material Universe, as well as those that are in Prospector, metals, and composites. So today, let's just look at the polymers, specifically the plastics. And now what I'll see is that I have 703 polymers to choose from. So you can imagine as a material scientist that's trying to solve this problem, that can be very daunting. You have to choose now from 703 alternate materials. But of course, don't worry, we will use the selector tools to actually help us out here. And we have this little thing called a reference, which will actually help us in terms of finding where that stainless steel fits that we're currently using. So in order to find our reference, I can just go here into search, So I know that the current steel we're using is a 304 half hard stainless steel, and I can set that as my reference material. So now if I go back, we'll see that my reference has been automatically updated. And the next thing I need to do is I need to actually start graphing these materials based on my constraints. I'm going to go ahead into the chart index tool, and I'm going to look at two things. So I'm going to look at the cost and the mass, but I don't want to just plot cost and mass by themselves. I actually want to plot them as a function of stiffness, because we know that we're stiffness limited. So one of the nice things that you can do is you can use the function and loading conditions to actually define your product. So here, with our sterilization case, we're going to look at a panel and bending. If I go down, we'll see that I also have thermal constraints, abrasion resistance, and electrical. So there's quite a lot of things that you can start to break down your product by. Let's go ahead and choose panel and bending. And here we want to optimize on the y-axis by mass. And then on the x-axis, we're going to optimize by cost as well. What you notice is that when I choose this cost, we have something here called the performance index, and this gives us a list of all of the different properties that are relevant for this particular selection. So we have C cost times the density over the flexural modulus, and that's what's going to be the units for my axis when I plot this. All right, so once I've plotted my list of 700 plus polymers, we're going to actually go ahead and just find our reference. So where does our stainless steel fit in this process? We can choose the little red pin, and that will select just the stainless steel here. So we're going to go ahead and pull that aside just so we know where it is. And looking at this chart now, what I want to think about is, if I'm minimizing cost and minimizing mass, I want to look at everything pretty much on this bottom left-hand side. So everything to the left and below our stainless steel is going to be a potential alternative replacement. Now, I could just get rid of all of these on the right-hand side by putting in a limit, but I want to make sure that I can see whether these are transparent or whether they hold up to medical grade first before I do that. And so what I'm going to do is I'm going to import some limits. So here I'm going to go to my limits, and I have now a selection of all of these different properties. So this is essentially all of the properties that are available within Material Universe. So you'll notice you have things like costing. So if I wanted to eliminate just all those materials that are more expensive than my product, I could do that here. For the sake of this demonstration, we're going to focus in on the optical properties first. So one thing to notice is that you'll see this reference column. So this reference column relates back to that stainless steel that we originally had. So we can see quickly that the stainless steel is opaque, right, for its transparency. So that's one of the problems that we currently have. We can't see what's inside the sterilization case. And so we want to select transparent or optical quality for our new material. And we can go ahead and hit apply. So once we've done that, we'll see that our list of results is actually whittled down to 103 out of 700. So there's not a lot of transparent polymers. Just about more than 10% in our database are transparent. The next thing we can do is to make sure that this is going to be a medical grade. So here under the healthcare and food column here, we have the ability to select by medical grade. So indeed, our stainless steel was a medical grade. It's good to know that we were using the correct material. But we can make sure that our new plastic is also a medical grade. And if we hit apply again, now we're down to 64. Let's go ahead and take a look at what this actually looked like on our graph here. So all of those circles that you see in gray now do not abide by our new condition. So they're either not transparent or they're not a medical grade material. And so I can go ahead and just hide those to make it a little bit less busy. So now we have a list of these 64 that are top candidate materials. And some of you may be asking, why are these not points? Why are they circles? And that's because each one of these properties actually has a range. And that range relates back to all those individual supplier materials. So if we just look at this red box here, this PIBA, there will be multiple PIBAs from different suppliers that have either a different mass or a different cost. And so that's why you see that kind of range or that circle value instead of just a single point. So that's something to keep in mind when we look at a specific supplier later on in this demonstration. But just to kind of move along, I'm going to go ahead and zoom in on this part of the graph that I'm interested in. And we'll see here that there's quite still a lot of candidate materials. So what we want to do is now to actually be able to limit by the ability of these materials to be sterilized. So it's going to be very important in terms of bringing down our cost. If we can sterilize these multiple times, we can actually reuse these cases. And so this is going to help us a lot in terms of our overall product success. So let's go ahead back into our limit. And here we're going to look back in the healthcare. And under sterilizability, we're going to look at a steam autoclave and make sure that we have an excellent property. So once I've applied this kind of last limit, we'll see that we're down to 5 materials on the left-hand side. And we can actually rank these materials based on either their cost or mass. So here I can look at mass, and it'll give me the values for all of the candidate materials. If I look back at my graph, and I adjust the window, we'll see that all of these materials here, these 5, are the top candidate ones. You'll notice that they are more expensive than our stainless steel, but they are much lighter. And because we can actually sterilize them, we can actually reuse them, and that will make up for a significant amount of this cost. So if I go ahead and just pull out a couple of these materials, let's look at the closest 2 here that are lowest in cost, and that's a PSU and a PEI. So the next thing I can do is how do these PSU and PEIs actually compare to my stainless steel in properties other than mass or cost? And I can do that by actually selecting this PSU here, and we're going to add it to a comparison table. So what a comparison table is a quick side-by-side comparison of our new candidate material and our existing stainless steel material. And here we're highlighting all changes in orange that are greater than 10% between the 2 materials. So you'll see that we have our difference in not only mass and cost, but we can also look at all data. This will bring up all the data that's available in material universe, these 2 materials. And if I scroll down, we'll see that there's quite a lot of differences between these 2, which makes sense because we're looking at a stainless steel versus a polymer, significant differences in mechanical and electronic properties. But really what we're looking at here is for the restricted substances. So in choosing this new candidate material, we want to make sure that if we put it in our product, it won't actually be later down the line affected by any kind of legislation that comes into effect, right? So if we look here, we'll see that our new polymer material on the right-hand side has an increase in its risk of being a restricted substance. So here we have our REACH candidate list indicator and our SIN list indicator. So these are 2 things that are collated by Granta, by material experts that we have, and they actually keep track of different legislations. Here we're looking at REACH, which is in the US, and that shows us that there is potential for one of the compounds within this polymer to be restricted in the coming future. It's been placed on a substitute now list, and so potentially 5 years down the road, this could be a risky choice. So this is a good thing to note. And if we go back to our stage, what we can do is we can actually look at including another material to see if there's an alternative that doesn't have as high of a risk as far as restricted substances. So let's go ahead and put our PEI into this comparison table. And once we've added that PEI, so our PEI is on the most right-hand side, and we'll see now that there is no risk of any restricted substances being introduced to this component over the next 5 years. So potentially now we have 2 alternatives. That's that PSU and the PEI, one of which has a risk of restricted substances, while another one does not. And so we can see that both of these are now candidate materials moving forward. So once we determine that these are candidate materials, the next thing we can do is to actually look at potentially buying one of these materials. And what we can do is actually scroll all the way down to the bottom here. And it will have some links here. So what these links are is essentially a way for you to access those individual supplier data sheets that I mentioned earlier that actually create those ranges of material properties. So with this PEI, we're going to look at the Prospector Plastics link. And this will bring up a list of all of those Prospector Plastics that are PEIs. And here we have them filtered by their supplier. So I'm going to go ahead and pull up this pyramid PEI that's made by Polymix. And I can look at its individual data sheet. So now I can see that there's no more range values anymore. We have individual values. And we have information about mechanical and physical properties. So we can start to get an idea of either feeding this in to our simulation models directly from this page, or we can actually go purchasing it. And if we want to purchase it, you can actually have a link here at the bottom that goes directly to that data sheet. So if I actually click on that link, it'll open up our Prospector Plastics, and it'll take us to this link. And here, this link has an opportunity of where you would actually purchase this. So here is the web link, or you can actually contact them to purchase it directly. So now we've quickly gone from a stainless steel material, introduced a couple of restraints, and we've ended up with a list of candidate materials here, which we can choose from, one of which being restricted substance and one of which does not. So we'll just hop back into our presentation real quick, and we'll go over a little bit of a summary. So as I mentioned, we came up with a list of 5 candidate materials. The 2 ones that we focused in on were PSU and PEI, and those were found to be up to 40% lighter than our stainless steel. The PSU specifically does have a low risk of containing those UV stabilizer substances, which could be restricted in the future. And even though both the PSU and PEI have a raw material cost that's 3 to 4 times higher, we can make up significant amounts of savings in the reusability of these because they're sterilizable accepted, or in potentially the assembly costs. So in the future, it's worth an in-depth investigation of both these 2 materials to see if they're candidates for replacement. So the next part of this is actually talking about Granta MDS. So any of you who are on the call who use ANSYS products, this will be especially relevant to you. So what is this Granta MDS product? Really, we start from that comprehensive list of materials. That same material universe that we talked about is where this data comes from. And we've essentially collated all of the simulation relevant data into a package of data sheets, the latest release of which contains over 700 plus materials. And this has both temperature dependent properties for a lot of materials, and it's got data specifically to support the simulation environment. So all of this data is embedded. So if you had ANSYS mechanical or electronics, as soon as you purchase MDS, you would essentially get that data directly within those 2 applications. As I mentioned, it's reliable data. It's collated by the material experts, and it's exactly where you need it. So you don't have to take any Excel documents and push those into ANSYS, or you don't have to ask your materials expert if he can send you the most up-to-date reports. You simply, in the ANSYS environment, you click on the Granta MDS library, and then you actually choose those materials that you're interested in. It really cuts the time down of your process significantly. So what are the material classes that are involved? We have quite a few metals, polymers, and composites. This is just a short list of all the different materials we have. If anyone's interested in any of these lists of materials, I can certainly send them out later. And what kind of properties do we have? So in the mechanical environment, the things we focus on, as I mentioned, are temperature-dependent models. We also have electrical and failure models, as well as isotropic elasticity, and some more advanced properties like hyperelastic. So, since the acquisition of ANSYS, we've been constantly adding new materials to this MDS product, and I imagine that every 2 to 3 months we will continue to get an update. So we've had, over the last 2 or 3 months, 300 more materials added on to what you're seeing here. So if you are interested in this product, just know that it is in the constant development, and we're always putting in new properties and materials. So as far as Maxwell electronic properties are concerned, we have BH curves, things like dielectric constant, in addition thermomechanical values as well, so thermal expansion coefficient specifically. So how do you actually access this data? It's really simple. What happens is when you open up the ANSYS mechanical environment, on the left-hand side, you'll see when you click on the geometry, in the bottom left, you'll see the ability to filter by the specific material, and you can select the Granta Materials MDS library based on that material. From there, you'll have a search bar where you can enter in the material you're interested in, and you can actually pull up those individual data sheets on the right-hand side that have your temperature-dependent data right there for you to use in ANSYS. So really, enough of me talking. The proof is in the pudding. This is really all of the customers that we have, Granta, now ANSYS, and you'll see that it's quite a large array of different industries. So we're not really focused on just one industry. We have solutions for pretty much every industry, as materials are quite prevalent across multiple industries. And then, of course, our integration partners. We work very closely with the companies that are mentioned down below. I want to keep it short and sweet. If anyone has any questions, feel free to drop them in the Q&A or to hop on your mic and ask them as well.
All right, thanks, Alex. And I'm going to go ahead and end the recording.